This is a coordinate geometry sum, which we call a curve sum, but in many of the coordinate geometry sum, the Cartesian equation is in cubic form, cubic polynomial form. So we need also the concept of cubics to do this Cartesian coordinate geometry curve sum. So in question number A, we have to show that point A lies on this curve. Obviously, point A is on the x-axis. So in order to do that, we have to just plug in the value of x and see if the value of y matches. So y equals to minus 2 cubed minus 6 minus 2 squared minus minus 2 plus 30, and this is minus 8, this is 4 6 24, this is minus minus plus 2 plus 30. Now we can see that this is 2 plus 30 is 32, minus 8 minus 24 is minus 32, so minus 32 plus 32 equal to 0. So hence A minus 2 0 lies on curve. Done. In question number B, what we have to do is find the coordinates of B and D. Now if you take a look over here, the coordinates of B and D, they both lie on the x-axis. So this has x coordinate B and this has x coordinate D. Now in order to solve this, we have to do this. At x-axis, y equal to 0. So x cubed minus 6x squared minus x plus 30 equal to 0. Now we have to find the values of x. Obviously there is going to be 3 values of x because it's a cubic equation. One of the value is here, minus 2. But what about the other values? In order to do that, we need to factorize a cubic equation, by doing long division. And we already know that one of the value of x is minus 2 and the value of fx would be 0. So that makes it, since f minus 2 equals to 0, x plus 2 is a factor. So this is one of the factor theorem that we can use, and we can factorize by long division. So let's do this. So we can do this, x plus 2, and this is x cubed minus 6x squared minus x plus 30. And in order to do this, we can write x squared. So x into x squared is x cubed plus 2 into x squared is 2x squared. Sign change, this thing and this thing cancels. Minus 6x squared minus 2x squared is minus 8x squared. We can just carry over minus x over here. Now we need minus 8x squared. So write minus 8x. So that turns out to be minus 8x squared. 2 into minus, this is going to be minus 16x. And again we have sign change, this thing cancels. 16x minus x is going to be 15x. And we have plus 30 over here. So we need 15 now. So plus 15. So 15 into x is 15x. Plus 15 to the 30. Again sign change. And this cancels off. Now this is a quadratic. So when we break a cubic, we get a linear and a quadratic. So let's break this down. So we know x squared minus 8x plus 15. So we can write, we know 15 is 3 5s are 15. So minus 5x minus thrice x plus 15. We can take x common, it would be x minus 5. We can take 3 common, it would be x minus 5. So the factors are x minus 3 and x minus 5. Now we can get back to the original equation that we want to solve. This is what we want to solve to find the values of x. Where does this curve cut the x-axis? So we can now write, instead of cubic equal to 0, we can write down the 3 factors. We can write, hence x plus 2, one of the factors, x minus 3, another factor, x minus 5, another factor. Therefore x equals to minus 2, or x equals to 3, or x equals to 5. We need to know the values of b and d. So that's what they rate. That's what they said. Find the values of b and d. So we know answer, b equals to 3 and d equals to 5. So the value of b and d is 3 and 5. Now the next question that we have is that the point E lies on the curve. The C here is the name of the curve. Both the point and the name of the curve is used capital letters to denote. So the point E is b plus d by 2. So we can find the x coordinate of the x coordinate of E. So we can write at E, the x coordinate equals to b plus d by 2. So b is 3, d is 5 divided by 2. So 8 by 2 is 4. Now let's find the value of y. And y equals, since x equals to 4, we can put here 4 cubed minus, let me check again, x cubed minus 6x squared minus 6 4 squared minus x plus 30 minus 4 plus 30. This turns out to be 64 minus 16 16 times 6 is 96 minus 4 plus 30, and this is going to be, so 64 minus 96 minus 4 plus 30, and it turns out to be minus 6. So this is going to be minus 6. Let me show you in the diagram where it would be. That means B is somewhere around here. E is somewhere around here. So this is E. So this is E, and the x coordinate is 4 and the y coordinate is minus 6. Obviously it makes sense because it's below the x-axis. So 4 minus 6. So the question is, find the equation of the tangent. So we know, in order to find the equation of the tangent, we need to know the gradient and the point. The point is E. So if you have a curve, so this is the curve, and at this point you have to find the equation of the tangent, and the point is 4 minus 6, and this is the tangent. So the equation of any line is y minus y1 equals to m, the gradient of that line, x minus x1. So this is the important rule, find the equation of any line. And the rule for gradient is the gradient of the curve is dy by dx at this point, and this is also equal to the gradient of the tangent line, which is m. That makes it m equals to dy by dx only for tangent line. So the first thing that we have to do is find dy by dx. So dy by dx, so let me write the equation over here. Y equals to x cubed minus 6x squared minus x plus 30. If we differentiate this, y is dy by dx, x cubed is 3x squared minus 6x squared is 12x minus x is 1 and the derivative of 30 is 0. So at the point E, x equals to 4, so the gradient of the curve dy by dx would be 3 into 4 squared minus 12 into 4 minus 1. This would be 16 into 3 is 48 minus 12 4s are 48 minus 1. So the gradient is minus 1. So this is the gradient of the curve, and the gradient of the tangent is also the same as the gradient of the curve at that particular point. So gradient of tangent is minus 1. Now the equation of the line. So equation of the tangent line is going to be y minus y1. The y coordinate of E is minus 6. So y minus minus 6 equals to m is minus 1. X minus x1 is 4. So this is going to be y plus 6 equals to minus x plus 4, which is going to be y equals to minus x minus 2. Now the format of the equation doesn't really matter unless this states specifically how the answer should be. So this is the answer. Now the next question is prove that the tangent at E passes through the point A. So the tangent at E has equation y equals to minus x minus 2. The point A has coordinates minus 2 comma 0. So we have to check whether point A lies on this. So let's check. So this means this is question number D. This means at A, x equals to minus 2. So let's put it over here. So y equals to minus of minus 2, minus x, minus 2, which is 2 minus 2, which is 0. So A lies on tangent. So shown. Okay, so what's happening over here? So this means the line that we have, this tangent, also passes through the point A. So it looks like this. Okay, it's more or less a straight line. So the tangent line looks like this. it is both a tangent to the curve at the point E, where x equals to 4, and it is also passing through the point A, where x equals to -2. So this is x equals to 4. Okay. This point is x equals to 3, and this point is x equals to 5, 3 and 5. Okay, so this is the question. Now the final question, question number E. So we have to find the area. So this is the area by integration. Find the area of the finite region. First of all, let's see what it looks like. So this is the x-axis. So we have this over here. We have this line over here. This is E. So this is 4. This is 3. This is 5. And this is -2. So let's see the region. The region is enclosed by the curve. So this is the curve by the line AE. This is A, this is E. So the region, curve line, and we also have the curve over here as it goes like this. So the region, there's no x-axis. The region is between the curve and the line. So this is basically a region which we call type 2. And this area is pretty straightforward. This area is going to be area above, which is the area 1, area of the curve. The area above is something like this area of the curve, and the area added to the area below, which is the area of the triangle. This portion, this can be done, but the best way to do this is not to bother about the area and think of this as type 2. And type 2 area is going to be area equals to integration limit from here. The region starts from -2 and the region ends at this point, which is 4. So -2 to 4, and the curve is above the region. So this is the curve, and the line is below the region. So this is the line dx. That's it. You can either do it by geometry, where you can find the region above the x-axis and the region below the x-axis. Instead of doing that, the best way to do this type of sum is just to think of, when you have enclosed region between a curve and a line, just to integrate and subtract the equation. So that's all you have to do. So we can do this. So area equals to integration. So the limit starts from -2 and the region limit ends at this point E, which is 4. So the equation of the curve which is above the region is going to be x cubed minus 6x squared minus x plus 30. So this is going to be this minus, and this is going to be minus x minus 2. So this give you a huge bracket over here, dx. Let me check again. So the equation is y equals to x cubed minus 6x squared minus x plus 30, and the equation of the tangent line is y equals to minus x minus 2. So y, we subtract two equations. And that's what we do over here. So let's simplify this. So -2, 4. This is going to be x cubed minus 6x squared minus x plus 30 minus 1 is plus x minus 1 is plus 2 dx. Then we can write -2 to 4 x cubed minus 6x squared. This thing and this thing cancels off, plus 32 dx, which turns out to be x cubed by 3 minus 6 x cubed by 3. This would be x to the power 4 by 4. One value increases, the other value will also increase. Okay. Plus 32x, and the limit is -4 to 4. It's a good idea to simplify your answers, so we can write 4 to the power 4 by 4, putting the value of x first, minus, if we cancel this, 3 to the 6, 2, this would be 4 cubed plus 32, this would be 4, subtract, this would be -2 to the power 4 by 4 minus 6 by 3 is 2, minus 2 cubed plus 32 minus 2. So this is going to be 4 to the power 4 divided by 4 to the power 1, 4 cubed. So this is 64 minus 4 cubed is 64. 64 into 2 is going to be 128, plus this is going to be 32 into 4. 4 to the 8, 128 minus, this is going to be 2 to the power 4 is 16. 16 by 4 is 4. This would be minus 4. Then this is going to be minus 2 cubed is minus 8. Minus 8 into minus 2 is plus 16. So minus into that is minus 16. And this will be minus 64. 32 into minus 2. Minus 64 into minus is going to be plus 64. Let's see what we got. We have 128 and 128 cancels off. 64 plus 64 is 128 minus, this is going to be 20. 16 and 4 is 20. This turns out to be 108. So let's do a recap. This is the structure, the general exam structure of every single exam, which is broken down into two papers, paper 1 and paper 2. We just did paper 1. So take a look over here. We already got kinematics, so we can cut off kinematics. So this is done. Kinematics is done. Then we had a quadratics inequality. We can find quadratics inequality. Then differential calculus product and quotient rule. So we can find differentiation calculus product and quotient rule. And then we did asymptote, so coordinate geometry. This is the sketching asymptote, this one. Then we had trigonometric 2D sum, which falls under trigonometric triangles, which is a sine rule or cosine rule. Then we did series, so series is here. We had GP series done, and then we did maximum minimum rate, so it would be under differential calculus. Maximum minimum rates is coordinate differential calculus. Then we had a question regarding quadratics alpha and beta or sums and products, so we had forming quadratic equations from roots. Then we had a question regarding trigonometric identities, so that turns out to be trigonometric identities, proving identities, and so that's that. And then we had coordinate geometry curve sum, where we had to find area. This was area type 2. So this was the coordinate geometry curve sum, where we had an area by integration. So whatever is left over automatically goes on to paper 2, because this is it. This is the question. So let's, before starting paper 2, you can have an idea. There would be a vector, because we haven't done vector. So where is vector? Is over here. So there would be vector in paper 2. Paper 2 there would be rate of change. Then paper 2 there would be trigonometry 3D sum. We had already done 2D sum. Then we have to do AP sum. So this is AP. There is supposed to be a binomial series, and that's how it goes on. Then would be graph plotting would be there. So it's pretty easy to figure out what would be in paper 2, because the exam structure is always the same.